In the last couple of videos, we saw how Entity Framework Core worked. In this video, we'll discuss more about mapping classes to tables in EF Core, focusing on mapping relationships. In the last example, we saw that we could create a model class like employee. Then we can use EF Core command line tool to generate the database table like this. If we look at the class and the table, we can see that property ID and name become column ID and name, and this is straightforward. But the employee supervisor property becomes an integer supervisor ID column, and this seems a bit magical, which raises a question: how exactly are classes mapped to tables? Well, the short answer is that they are mapped in the same way that ER diagrams are mapped to tables. For example, in the case of the employee class, the equivalent ER diagram is this. And from this ER diagram, we can easily convert it into a table, which happens to look like this table. In ER to relational conversion, the key thing is the conversion of the relationships, like the supervisor relationship here. It's the same in object relational mapping. Note that in ORM, a property of simple type, like a number or a string, is just like an attribute in a ER diagram. They simply become columns in a table. But if a property is of a class type or a collection type, like employee supervisor here, it actually represents a relationship. Oftentimes, they are also called associations. The tricky part of object relational mapping is mapping these relationships. And just like in ER to relational conversion, the key of mapping relationships is to determine the relationship type. Remember that if it's a many-to-many relationship, we need an actual table. But if it's a one-to-many / many-to-one relationship, we only need an actual foreign key column. Comparing to ER to relational conversion, mapping classes to tables is more difficult because it's hard to determine the relationship type just by looking at the classes. This is because one class only shows one side of a relationship, and there are different ways to design classes for the same relationship. Take this for example. If I give you this ER diagram, you can immediately say that projects and employees have a many-to-many relationship because there's no arrow on either side of this relationship. And as we know, a many-to-many relationship means two things. A project can involve many employees, and an employee can participate in many projects. Things are less clear with classes. For example, if I give you this project class, can you tell the relationship between projects and employees? The answer is actually no. What this class tells us is that a project can involve many employees. But as we know, it's only one side of a relationship. This class doesn't tell us whether an employee can participate in more than one project. And without that information, we cannot determine whether the relationship should be one-to-many or many-to-many. Same if we only look at the employee class. Here it shows an employee can participate in many projects, but not how many employees can a project have. Now, what if we look at both classes? Can we now say there's a many-to-many relationship between projects and employees? Well, technically, still no. Because we cannot be certain without some additional information outside the classes themselves that these two properties, employees and projects, are referring to the same relationship. And this brings us to the second issue in mapping classes to tables. There are different ways to design classes for the same relationship. For example, we know projects and employees have a many-to-many relationship. But when we design the classes, we don't have to include a list of projects in the employee class. This is known as a unidirectional association design, meaning that we only include one side of a relationship in class design, and from a class design perspective, it's perfectly fine. Same if we decide to include a list of projects in employee, but not a list of employee in project. And of course, we can include both, and this is known as a bidirectional association design. So what this means is that object relational mapping, for the most part, is about making relationship types explicit based on some assumptions and/or some additional information outside the class themselves, so the ORM tool can convert between classes and tables automatically. In Entity Framework Core, mapping, which is also called configuring, can be done in three ways. By convention, meaning that we don't have to do anything extra, and the EF core will try to figure out the mapping based on some assumptions. If that's not enough, we can add additional information using data annotations. And if that still is not enough, we can add some additional code using the so-called Fluent API. And if there's any conflict, Fluent API takes precedence over data annotations, which takes precedence over convention. Let's use this example to see how it works. Suppose we have two classes, customer and account, representing customers and their accounts in our bank system. We'll start with a simple design with customer having three properties: ID, name, and address, and account having three properties: ID, balance, and date created. Here are the two classes. Now let's run EF core command line tool to see what tables we get. We'll first do the migration, and then we'll output the migrations to a SQL script. So these are the tables our classes are mapped to. Again, ignore this EF migrations history table because it's a table used by EF core itself. Our tables are the accounts table here and customers table here. From this example, we can see some conventions used by EF core. Specifically, the names of the DB sets become the names of the tables, and the property names become column names. In particular, if there is a property called ID or class name ID. EF core will consider it the primary key column. And depending on .NET types like int, string become SQL types like SQL int and SQL varchar or nvarchar. Depending on whether the .NET types allow null or not. For example, string is a reference type, meaning that it allows null, and int or datetime is a value type that cannot be null. We can see that the SQL site will have either null, meaning that it can be null, or not null, meaning that this column cannot be null, depending on the .NET type. Sometimes maybe we don't like the default names or types, or maybe we already have a database and the names don't quite match with the default names. We can customize the mapping by using data annotations like this. In C#, we can add metadata to code using the so-called attributes. C# attributes are covered in one of the midterm presentations, so we won't get into details here. Basically, they're like Java annotations. Depending on the type of the attribute, we can add it to a class, a field, a property, and/or a method. Some attributes also take parameters. For example, here the table attribute has a parameter name. This example shows a few data annotation attributes. The table attribute can be used to set the table name if we don't like the default table name customers, for example. Required and max length can be used to customize a column. For example, C# string can be null, but we may want to say that the column cannot be null. And in that case, we can use the required attribute. And instead of nvarchar max, which would be an overkill because name cannot be that long, we can say the maximum length of name is 255 characters. So let's see how it works. We'll add the table attribute to customer, and then we'll add required and max length to name. If we redo this, we can see that now the customers table becomes clients table, and the name column has a maximum length of 255 characters, and it has a not null constraint now. Here are a few more attributes that are commonly used. Column lets us set the column name if we don't like the default name. Key can be used on a property that is not called ID or class name ID to indicate that it's a primary key property. Not mapped is quite useful if you have some properties that you only use in C# but don't want to save in the database. Foreign key and inverse property are used when mapping relationships, which we'll talk about in a moment. Now that we saw bi-convention and data annotation, this is the third way to configure mapping using the so-called Fluent API. To use Fluent API, we need to override the onModel creating method in FDB context. So let me copy and paste this to here. And here inside the method, we can use the model builder to configure mapping. For example, here the code is basically saying that the address property of the customer class should have a default value 123 Main Street. Now let's run our script again. So here, as we can see, this basically adds a default constraint to the column. So if a record is inserted into the table and the record has a null address, the address will be set to 123 Main Street instead. Fluent API can do lots of things. Here are the common ones that you need Fluent API for. Or in other words, you cannot do this with either bi-convention or using data annotation. As we just saw, setting default value on column requires Fluent API. So does setting unique constraint, creating indexes, and specifying a key with more than one column, which is known as a composite key. And as we'll see in a moment, bi-convention is actually good enough to handle most of the relationship cases. But in the cases that bi-convention cannot handle, we'll need to use Fluent API. By the way, we don't have time to show examples and syntax for everything. So please check out the documentation, especially the section called Creating and Configuring a Model. It includes basically everything related to mapping a class to tables. Okay, now let's talk about mapping relationships. As we know from ER modeling, there are three main types of relationships: one-to-many / many-to-one, one-to-one, and many-to-many. Let's use this example to explain some terminology used by EF core. First, note that there's a one-to-many / many-to-one relationship between customer and account. Specifically, a customer may own many accounts, and each account can only have one owner. In a one-to-many relationship, the one side, in this case, customer, is called the principal entity or parent entity, and the many side is called the dependent entity or child entity. The key of the principal entity is called the principal key, and in the dependent entity, there's a foreign key which references the principal key. The accounts property in customer and the owner property in account are called navigation properties, meaning that we can navigate from one object to another by following the object reference. In our example, we include both the foreign key property and the navigation property in account. I highly recommend that you do this because not only it makes mapping easier, it also makes using the class easier later because it gives you the flexibility to use either the foreign key property or the navigation property. That being said, if you don't want to include the foreign key property or even the navigation property in the class, it will still work. It's just less convenient. Now, given this one-to-many / many-to-one relationship, let's see how to map it. We'll consider both bidirectional and unidirectional association design, as well as including either, both, or none of the foreign key property and the navigation property. First, let's try this unidirectional mapping with account having a reference to customer, but no list of accounts in the customer class. This is a common class design for one-to-many / many-to-one relationships, as it closely matches the relational design, because as we know, in the relational design, the accounts table will have a foreign key column. There's no additional columns in the customers table. So in this design, we will have owner ID, the foreign key property, and owner, the navigation property in account, nothing in customer. So let's see. Now, if we look at the tables, we can see that the customers table looks the same as before. The accounts table now have an additional column called owner ID, and this owner ID is a foreign key column, references the customer ID in the clients table. So in other words, by convention handle this case just fine. EF core recognize that owner ID is the foreign key for the owner association. There's no additional configuration needed. Now, if the foreign key property name does not match the navigation property name, for example, suppose instead of owner ID, we say my owner ID here, then EF core cannot recognize automatically this one is the foreign key property of this one, but we can use a foreign key attribute to indicate that. So we could say, for example, foreign key my owner ID, and this is enough to tell EF core that the foreign key property of this owner navigation property is my owner ID, so it will map it correctly. Now, what about this one? In this unidirectional association design, customer has a references to the accounts the customer owns, but no reference in the account class back to customer. Meaning, instead of this side, we have this side. Now, as we can see, by convention still maps this case correctly. The foreign key column now has the name customer ID instead of owner ID, and that of course comes from the class name customer. And if we want to customize it, we'll have to use Fluent API to do that. But otherwise, by convention handles this case perfectly fine. Now, the more interesting question here is why by convention still works in this case. As we said earlier, a customer has a list of accounts. Doesn't necessarily mean customer account relationship is one-to-many, because it could still be a many-to-many relationship where we simply omitted the list of customers in the account class for a unidirectional association design. The reason it works here is actually simple. EF core simply assumes that this is one-to-many. In this case, it indeed is, so it works out fine. What if it's actually a many-to-many relationship instead? Well, in that case, we can always configure it using Fluent API. So what about bidirectional association like this? Well, let's see. In this case, now we again have owner ID here and owner here. And owner ID being a foreign key references customer ID, and again, it works. And again, this needs a bit explanation. We said earlier that just by looking at these two classes, we actually cannot be sure there's a one-to-many, many-to-one relationship here, because these two properties could be representing two different relationships instead of the two sides of the same relationship. Here, EF core again makes the assumption that it is the latter case rather than the former, meaning that it assumes these two properties represent the two sides of the same relationship rather than two different relationships. If that assumption is wrong, we can override it by manually configure it using Fluent API. And okay, so Where am I? Yes. And in addition to, so I want to mention another common case here, which is when there are more than one relationships between two entities. For example, suppose an account can have one primary owner and many secondary owners. For example, we will have another property called secondary owners. Now, in this case, notice that there are actually two relationships between account and customer. One is one account has one primary owner, and the other relationships is one account can have many secondary owners. Now, in this case, EF core will not be able to determine if the accounts property here is the other side of the owner relationship or the other side of the secondary owners relationship. And in this case, we can use the inverse property attribute like this. We can say inverse property owner, and this tells EF core that this property accounts is the other side of the owner relationship rather than the other side of the secondary owner relationship. And inverse property is a pretty useful attribute when we have more than one relationship between two classes. Now, there's yet one more case where we actually don't have any navigation property on either side. As we can see, there's actually no indication in the class design that these two classes are related to each other. As you can probably guess, in this case, we'll have to use Fluent API to tell EF core that these two classes are indeed related. Basically, we'll have code like this, and it's basically saying that account has one is related to one customer, and one customer is related to many accounts, and the foreign key is the owner ID property. Okay, so that's about it for mapping one-to-many and many-to-one relationships. And once we know how to do that, one-to-one is easy because it's just a special case of one-to-many where the foreign key can be on either side. But what about many-to-many? Well, let's see. Suppose we allow each account to have more than one owner, then account customer relationship becomes a many-to-many relationship. So that means a customer can own many accounts, and account can have many owners. Now, if we look at the tables, we see a third table, account customer, and it has account ID, foreign key column references the account ID in the accounts table, and it has a owner customer ID column. Foreign key column references the customer ID in customers. So in other words, it still works. In particular, by convention still works, meaning that we don't have to configure anything extra, and it somehow figures out that these two represent a many-to-many relationship. Now, in this case, once again, EF core is making an assumption, and that assumption is these two properties represent two sides of the same relationship. If that's not the case, we can use Fluent API to configure them. Otherwise, by basically doing something like this, we'll say account has many customers with many accounts, and something like that. So far we've seen how to map collection of class types. What about collection of simple types, like a list of string? For example, suppose we want to store a list of phone numbers for each customer, and the phone number is just a string. This seems to be a pretty common and pretty simple case, but surprisingly, EF Core doesn't support this directly. So let's, for example, remove the migrations, and let's add a property here that says list of string forms, and if we try to create a migration, we'll get an error, and the error says the property customer forms, which is this one, could not be mapped because it is of type list of string, which is not a supported primitive type or a valid entity type. What this means is that we cannot do this directly in EF Core, and to make it work, we actually have to create a new class. This class will use a key of customer as part of this key, and if you remember ER modeling, you'll recognize that this new class will be a so-called weak entity set. And this is what the class would look like. Notice that instead of a list of strings, customer has a list of customer form objects. And each customer form belongs to a customer. So here we simply have a one-to-many relationship. Now let's try to map it and see what happens. We'll have a new class, customer form, and make sure these are all properties, not fields. In my notes, I write them as fields just to save some space, but they should be properties. And now this one will be a list of customer forms. Yes. Foreign key, navigation property, and property, yes. Now, if we try again, we get another error, and this time it says the entity type customer phone requires a primary key. And remember, by default, EF core looks for a property called either ID or class ID as the primary key for the class or for the entity, but there's no such property here. There's no property called ID or customer phone ID, for example. So what should be the property for this class? What should be the key for this class? Well, take a look at the table here. Notice that customer ID cannot be the key because a customer can have multiple phones, meaning that there could be multiple rows in the table that have the same customer ID. In other words, customer ID is not unique. It cannot be the primary key. What about phone number? Well, notice that the same phone number can be shared by two customers. Maybe they live in the same house or something like that. And in that case, again, we'll have multiple rows with the same phone number. So phone number by itself cannot be the primary key. So the key of the table, in fact, is the combination of both customer ID and the phone number. Again, if you remember ER modeling, this is basically how the key of a weak entity set works. It's a combination of the key from the supporting entity set, in this case the customer, with some attributes of its own, in this case the phone number. Now, if a key consists of more than one column or property, then it's called a composite key. In EF core, we need to use Fluent API to configure a composite key like this. So this one basically says customer phone has a key, and this key is a combination of customer ID and the phone. Now, with that, if we try again, this time it works without any error. And if we convert it into SQL statements, we see that we have the customer phone table here with customer ID being a foreign key references the customers, and the primary key of the table is a combination of customer ID and phone. So this is the correct relational table mapped to the class design. So to quickly summarize relationship mapping in EF core, the good news is that by convention and the data annotation together can actually handle most cases. This is really good news because most of the time we don't need to write any additional code to make it work. It's quite convenient. One notable exception is a unidirectional many-to-many relationship. In that case, we'll need to use Fluent API to tell EF core that it's a many-to-many relationship, because otherwise EF core will assume it's one-to-many. Now, the bad news is that there's no simple way to map a collection of simple type, like a list of string or a list of integer. This is kind of a bummer. I hope EF core will add support for this soon. But even with this missing feature, EF core is still a superb ORM solution. I'm sure the more you learn it and use it, the more you'll like it. For readings, please check out the Creating and Configuring a Model section in the EF Core documentation. And thanks, and see you in the next video.